Okay, 6.2, it's on tangent properties. A tangent is a line drawn to a circle and it's perpendicular to the radius at the point of tangency. So if I draw in my radius here, my radius and my tangent are perpendicular to each other. And my tangent only touches my circle at one point, and that's the point of tangency. All right, so if two segments from the same exact exterior point are tangent to the same circle, then they are congruent. So AB and CB are going to be equal because they are both tangent to the circle and they both intersect at point B. We have what's called a circumscribed polygon, and that's when my polygon is made up of all tangent lines and my circle is in the interior. So the circle touches the polygons at, in this case, only in 4 points, in these 4 points. Okay? With circumscribed polygons, it is still two lines of tangency, or two tangent lines that are coming to my circle. So that means that this line segment and this line segment are congruent. Same over here. This one and this one are congruent, so those are both x's. So we can make the same information here based on what is given to us. So it is find x, and the perimeter is 18 units. So let's add up all my terms on the outside equal to 18. So I have 4 3's, and I have 4 x's. It's going to be equal to 18. 4 times 3 gives me 12, plus 4x equals 18. I'm going to subtract 12. 4x equals 6. So x equals 1.5 or 3, 3 over 2. Either one of these is acceptable. Okay, so we can use that idea about our tangent lines being congruent to help us find that missing value. When you have two lines that intersect at an exterior point, then the angle formed is half the difference of the measures of the intercepted arcs. So that's a lot of words, and really what that means is we're going to take our big arc and we are going to subtract our small arc and it's half of that. So you can either say times 1/2 or you can divide that by 2. I like to divide it by 2, but it's the same thing as times it by 1/2. So in all of these pictures, I'm taking the big arc minus the small arc, and I'm dividing it by 2. So let's do some examples with this. It says find angle S. So we don't know what angle S is, okay? And I have a big arc here of 179, and I'm going to subtract my small arc, 71, and divide it by 2. This will find me angle S. So 179 minus 71 is 108, and I'm going to divide that by 2. So I get 54 degrees for angle S. Big arc minus small arc, divide by 2. Sometimes, as in this picture, we're only given one arc, and we're given the smaller arc here. Okay, we still are finding the angle L, but we can use our knowledge about circles. These arcs intersect at this one point. So 102 goes from here to here, and then my big arc is going to go from that point all the way around. Well, what does a circle add up to for their angle measures? 360. So if I take 360 and I minus my 102, that's going to give me this arc. So we end up with this arc being 258. So now we can still follow the same idea. Take your big arc minus your small arc, divide it by 2. So 258 minus 102 gives us 156. We're going to divide that by 2. And so our angle gives us 78 degrees. And in this last case, they give us our angle, our small arc, and we have to find our big arc. So let's just call our big arc x. So big arc minus my small arc, divide by 2, is equal to my angle. So I'm just going to work this out. Multiply both sides by 2. X minus 95. 56 times 2 gives us 112. Okay, so now we're going to take 112 and we're going to add 95 to it. When we add 95 to it, we get 207. And this is still degrees. Arcs are given to us in degrees. All right, so here's some practice problems for these terms.